Hello, this is Henrik Beshman. I'm a software developer in Toronto. My website is internetcommons.ca, and this is the, I believe, seventh screencast in my series, What is Drupal?, in which I put forward the proposition that the key properties of Drupal, and the best way to understand Drupal is to think in terms of 5 characteristics. 1, resource manager, 2, a configuration manager, 3, a content manager, 4, a state change machine, and 5, a rapid application development tool. In this screencast, I'll be looking at the notion of Drupal as a state change machine, which is kind of a model in my mind of how the code is organized. In fact, I think of that aspect of Drupal, the code organization, the dynamics, as a dispatch-driven state change machine with a service-oriented architecture. The service-oriented architecture is a pretty straightforward idea. It's just the notion that modules are really services, and I think a careful examination of the dozens and even hundreds of modules that are sometimes installed for a system bear out the notion that those modules are really services to the website. So I don't think there's any difficulty with that. In terms of the state change machine, what I mean by that is that the custom code and any code in the application really has dozens or even hundreds of opportunities through these things called hooks that are really callback mechanisms. Dozens or hundreds of opportunities to change data, and through changing of that data even change the control of flow that takes place for each call to the website. There are literally hundreds of these callbacks that are available to modules. If you go to Drupal.org and have a look at this topic hooks, you'll see them listed here, and these are just the callbacks that are available from the core itself, which is, I don't know, typically about 2/3 of a website implementation. So, you know, there might be 3 or 4, well, if there are 300 in the core, there might be 400 or more callbacks available to any particular module in the application, or in particular to your own custom code if there are some modifications that you want to make. But it turns out that there is some similarity to the patterns involved here, and one of the similarities is that many, if not most, of the calls that are made through these through this callback mechanism are generated by a very few key dispatchers: module invoke all, Drupal alter, Drupal get form, and theme. We'll have a little bit of a look at those. A good way to get a sense of all this is to follow the code at a high level from the index.php loading file onwards. So let's have a look at that. So here's index.php, and as you can see, it's quite simple. It calls Drupal Bootstrap, and then calls menu execute active handler. So let's just have a quick look at Drupal Bootstrap and see what it does. So here it is. I'm getting this from api.drupal.org, although I could just as well look in the source code directly. So Drupal Bootstrap does, you know, the sort of thing that you'd imagine goes through a few steps to assemble resources needed in memory, and then calls Drupal Bootstrap full. I've preloaded that. That does a few things like load modules, initialize a few things here and there, And there's the first call to module invoke all with the argument of init. So what module invoke all does is just simply collect all the functions that have been registered by modules, and there could be dozens of them, that pertain to the particular hook, in this case init, that is being called. It collects them all and then runs them all. So I mean, in that sense it's pretty straightforward. And you'll notice that the arguments are open-ended. It just takes whatever arguments it finds and passes them on to the arguments, although to the registered functions, although there tend to be conventions for those. There are many calls to module invoke all. Just doing a search here of a local copy of the Drupal 7.23 installation that I have, and as you can see, there are 56 calls to module invoke all within just the core software, and again, many modules use this method as well to provide other modules access to the possibility to modify or change the state of the data that the modules have. So it's quite a common usage. So right from the Bootstrap process, we have the first invocation of this sort of massive call to any modules that have any kind of an interest in this particular event. So going back to the index.php, we've now been through the Bootstrap process, and the next thing that happens is menu execute handler is called. And menu execute handler essentially looks for the menu that's been called, and in particular a page callback from that menu execute handler. So there's the call to the menu page callback, whatever has been found. And as an example, I've gone into the node module itself. So here is a menu item with the page callback of a node page view, and that's just the familiar node and then a node number, which results in a call to view the page. The node module has quite a few of these menu items and callbacks registered. As do many modules, and as can custom modules. That, of course, can go off in any kind of direction, but let's just assume for the moment that a simple, if there is such a thing, simple callback happens, the page information is assembled, and then what happens is that this high level, we're back in the menu execute active handler, which is really just calling the page callback. Once that assembly of data is complete, then Drupal calls a function called Drupal deliver page, and here it is. It then uses, and you might have noticed this from other code that I've just showed you, Drupal deliver page also allows modules to alter data of various kinds through this Drupal alter routine, in this case by substituting the callback itself, but it could be anything. We'll get into that in a bit. But anyway, Drupal deliver page calls Drupal deliver HTML typically, and that in turn calls the theme I'm sorry, it only calls the theme as an exception at this stage, just for a maintenance page if things don't go well. But if things do go well, then this function Drupal deliver HTML page in turn calls Drupal render page, which uses again this function Drupal alter to give any modules that have any interest in changing the page before it is rendered. And again, Drupal alter is very commonly used. So here again, let me just do a search on a standard Drupal install. Drupal alter is used something like 52 times. Really what it does, let me just go and grab it here. Is find out what modules have implemented that particular hook, and then it just goes ahead and calls them. Right at the bottom here, there's the indirection, and it calls them with a standard general format, so data, which is not changeable, context, various contexts. Sorry, all these things are changeable if the receiving function, if the calling function receives them by reference. So it's an opportunity. It provides an opportunity for any module to change data on the fly. So let's go back to the page. Render page. So once modules have been given a chance to change the structure of the page, then Drupal render is called. And again, that's a very common usage, and it's also recursive. And Drupal render goes through a process of identifying elements in the data structure that should be rendered, or children. Drupal render takes as an argument a renderable array, which is one of the key concepts, which is the closest thing that Drupal has to a data model. And that render array is an associative array which has fundamentally two kinds of keys. One is a set of keys that is prefixed with a hashtag or pound sign, a hashtag, I guess most commonly, and keys that do not have a hashtag. The essential difference is that keys that have a hashtag are considered properties of what's essentially an abstract data type, or properties of the item or element being rendered, whereas keys without the hashtag are considered placeholders for children. And so that is what makes the process recursive. So there's a little bit of logic here, but I mean, you know, essentially the items are generated into an HTML. Now, a key part of this process of generating an HTML string is to pass information, again on a recursive basis, to a function called theme. And here it is. And a theme sorts out the various templates and functions that are used to combine data with templates in order finally to generate the HTML string or the output at the end. So let's just pause here for a second and go over what we've learned. Fundamentally, the way Drupal works is it goes through a bootstrap process, looks for a page callback function, runs that page callback function, which collects data, assembles a data structure, and then renders the page. And in the process, any of these steps can invoke multiple calls to module invoke all, which itself with some kind of specified name, which itself can call dozens of functions that have been registered by modules, and they in turn can call more. There can be a really busy cascading effect of calls here. In addition, any of the functions or modules can collect some data and call Drupal alter, again with some naming conventions that allows for any modules that have registered an interest in this essentially to receive a copy of the data such that they can make a change on the fly. And then all those things call theme, which itself is recursive, and can call a number of registered functions that can be registered by any module. So it's a very busy, very open-ended process, but fundamentally what's involved is that modules register an interest in a particular stage of the process, typically some kind of an object such as a piece of a form or a piece of a page, and some step in the process, like some method in the process. They register an interest in that. They expect to be given or handed through that callback some kind of data, whether it's a renderable array or an entity data or something else, and they expect to be able to make changes to that data to influence the outcome, influence the content, or even influence the process in some way. So it's very open-ended, and it is consequently very flexible, and provides the basis for the ability of module writers to have contributed such a rich variety of modules to Drupal. Again, keep in mind that Drupal itself, most of it consists of modules, so it uses this method itself to provide the foundation functionality through assembly of these services through modules, and then simply offers the mechanisms that it itself uses to anyone who can contribute modules of their own. And we've seen that the overall process is actually at a high level pretty straightforward. There's a bootstrap process. A menu action is called, which either performs an operation on the database or collects some kind of information to present to the user. That is assembled into a renderable array. It's handed to the page, then modules are given a final chance to alter the page, and then the page is rendered, which is to say the elements of the page are combined with templates in a recursive manner, and then handed back to the browser. What I've said is fairly abstract, but it's a recurring pattern and quite a firm pattern, and you know, what I've found, and I think what others have found, is that once you have that pattern in mind, then it's just really a matter of experience, examining documentation, and sort of narrowing your focus to a very small slice of the process that takes place to begin to be able to influence the production of web pages, even complex web pages, according to the specifications that you've been handed. Just as sort of a more concrete demonstration, what I've done is created a number of these callbacks to do with the node, loading the node, pre-processing the node, viewing the node, altering the node, and then finally altering the page. This is a debug function that prints messages to say, you know, what's happening here. This was getting overwhelming in terms of the amount of information that was being handed back, because it's called so often, but I've just provided a feedback message there to indicate what that this pre-process, kind of generalized pre-process callback was being called. But the others actually not only indicate the call that's being made, but also print out the data that is being, or some of the data at least, that's being handed back to the module for modification. So just to have a look at my demo website, this is vegetableddiet.ca. It's a fairly simple website. It's about a way of eating. We just happen to be on our recipe page here, and so let's go in and see the results of these callbacks. So as you can see, quite a number of callbacks have been made, and in each case the callbacks are provided with data. So in this case, the load callback is handed the entity that is being loaded. In this case, it is node number 18. There's the title, curried fish soup, as we saw, and a number of the properties, most of them from the database, from the base table and the entity field tables of the database. There's the body, which if you watched the previous screencasts, you'll know came from a field table. And there's the actual HTML, which by now has been already rendered. Sorry, it hasn't been rendered. That's just the copy of the field from the database. There's the image data with 1, 2, 3 images, also from the field table. So essentially, at this point with the load, really all that's happened is that the module is being handed a copy of the entity, and the module at that point could make modifications to that data if they wanted the information being presented to the user to be altered in some way. The next call is a view call, which essentially has the same data, except it's got a new property here called content, and this actually is the beginnings of a renderable array for the Drupal render function to work with. And then the build is simply, the build callback is simply essentially handed this content. So you can see body pre-render, etc., body pre-render, and so forth, leaving the underlying entity data behind, because at this point the process doesn't care. It's already assembled what it wants to. This build callback is just simply giving the module a chance to make some final changes. And then the page alter callback is given the entire page, with the content for the page, and you'll see that the node Renderable Array is now embedded in the page. So there's the header for the page. There's the block HTML that I produced for a block, and it's been assembled for the page. At the bottom of the page, there's the system powered by and so forth. So really all the data that's going to be required to render this in HTML has been provided. So it's a wonderful and horrifyingly complex process. But at base, when you take it step by step, it's really brilliantly simple. In other words, the underlying concept is that callbacks are registered. And incidentally, when I say callbacks are registered, there's nothing special has to be done. You just register, you just create a function in your module. And because of the properties of the PHP interpreter, Drupal is able to simply load that module, and PHP places those function names into an array which can be queried by Drupal, and so it can find out essentially whether you've created a function or not simply by determining whether you've done so. So no special registration activities that's required by the developer. It's just a matter of creating functions using particular name conventions. The developer needs to understand that Drupal essentially relies on name mangling of functions. In Drupal 7 still doesn't rely very much on object-oriented structures or programming, although that's going to change with Drupal 8. But in any case, it's a question of registering callbacks, becoming aware over time of what those callbacks are, expecting that those callbacks are going to be given data that is expected in the early stages of assembly. The callbacks are going to be handed essentially more or less raw data or entity data from the database. In the later stages, the callbacks are going to be handed arrays that are in a form, again, which have highly conventional structures that are ready to be rendered by some of the core functions of Drupal. Another point to make here is that to the extent that modules do not provide wrappers and themes and styling and such for the data that's pulled from the database and is intended to be presented to the user, Drupal always provides defaults. It has a bunch of default types. So let me just find those. There's a function in the system module called system element info that actually provides all the defaults that Drupal uses. And incidentally, also on Drupal.org, you can find this particular node that talks about render arrays. Highly worth it. It's probably the single most important page that I found, and the page that helped me the most in making sense of this process. But in any case, fundamentally the process is that modules register callbacks. The callbacks are handed data. The callbacks are able to modify that data again in very specific ways. And of course the developer has to be aware that there are all kinds of other modules that have their hands in on this as well, and order of processing can make a difference and so forth. So it can get complex, but the fundamental process is really pretty simple. namely that through this module invoke all and Drupal alter, developers are handed data at very specific points in the process, such that they're able to make modifications to that data to get the outcome that they want. The final call that I showed of the page, which is hook page alter, even allows the developer to rearrange the order and the content and layout of the page at the last moment, for example. And that is actually something that is, if not encouraged, at least sanctioned. In other words, developers nowadays are encouraged to, or discouraged from generating HTML partway through the process, but rather in their page callback functions, they're encouraged not to return HTML strings, although they can and that'll still work, but they're rather encouraged to return renderable arrays so that other modules can make modifications to their data, including over time their own modules, perhaps at a later time. It's just a good habit, so that the only Drupal render call ultimately and ideally would be made at the very end by the Drupal render page call. But again, fundamentally the process is that there is a cascading set of dispatches made by a very few number of core methods, and those dispatches generate calls to functions that are handed data that can themselves alter control of flow subsequent in the process, such that as this process continues, a data model or a renderable array for the whole page is assembled and finally rendered and combined with templates and returned to the browser. So I call it a state change machine because it's such a dynamic thing. Essentially, you know, I think an accurate way of looking at it is that when a developer registers a callback and is handed some data, in essence, what they're getting is the state of the page as it's being assembled at that split second in time. And what they're able to do is change the state of that data and even the control of flow. So I think it's pretty accurate to call it that. So once you've wrapped your mind around that and perhaps examined a number of these methods in some detail, then it becomes a lot easier to gradually gain experience and insight and knowledge into the more particular steps that are taken. For the themers out there, I highly recommend that you actually go and find this theme function and read through the code to see what it does, because it'll give a much clearer idea of how and when things are called. So there it is, Drupal, a state change machine, or more particularly a dispatch-driven state change machine with a service-oriented architecture. I'm Henrik Beshman of internetcommons.ca.